Hello and welcome back to the next session. In the earlier session, we had talked about the key constraints, functional dependencies and other things for the relational database management systems. Now we see what are the anomalies, and in order to avoid the anomalies, what kind of process we have to follow. So let us start with the functional dependency once again. A functional dependency describes a relationship between attributes with a single relation. An attribute is functionally dependent on another if we can use the value of one attribute to determine the value of another. So these functional dependencies we can understand with the help of an example. Like suppose if a relation contains employee social security number, employee name, employee address, department he is working with various fields, and then whenever we want to retrieve the record or whenever we want to retrieve only the employee name by placing a query, we can use the SSN number, social security number, as the key to retrieve the employee number. So for whatever the employee name may be, directly by placing the SSN number we are able to retrieve the employee name. So likewise, suppose if you want to retrieve the salary against one of the SSN social security number, then also we can do. So within the relation, some of the fields are functionally dependent on the other field. So this functional dependency can be represented as X forward arrow Y, that is nothing but X functionally determines Y. In the above example, I can say SSN functionally determines the employee name. Likewise, we have several examples over here, like student ID functionally determines student major, student ID, course number, semester combinedly functionally determines the grade. Likewise, we were given several examples over here. Then let us see the anomalies in the database management system. Once the design of the conceptual schema using the entity relationship diagram has been converted into relations, we may find that some relations are not properly specified. There can be number of anomalies. Like you had designed the blueprint or as the conceptual schema using the entity relationship diagram. If it is been converted to the relations, within the relations you could have identified the keys also, like which is the primary key, which is the foreign key and the other keys. So along with that direct conversion, you will be getting only the unnormalized tables, not the complete proper database. However, it may suffer with certain anomalies. There are three types of anomalies we can observe for these unnormalized tables, and it requires a kind of process called as the normalization in order to prepare it for the final. So there are three types of anomalies that one can identify. One is the insertion anomaly, second is the update anomaly, third is the deletion anomaly. First one is the insertion anomaly. Insertion anomaly, let us observe a simple example. Suppose if a company stores the employee details in a table named employee that has 4 attributes: employee ID, employee name, employee address, employee department, and whenever you want to, and this is the unnormalized table we are getting. You can see over here Rahul is the employee name with employee ID 101 and it is being repeated twice. Why? Because Rahul is working in 2 different departments. He is working in 2 different departments, department 1 and department 2. So that is the reason why we had given the database is given as created 2 different records for Rahul. So likewise here Ganeshan also, he is working in 2 different departments, D900 and D904 in Chennai. Why this particular two values came? Because in the same row we can't store two different employee departments. EMP department can't be stored twice. Why? It should have atomic values in the columns. So that is the reason it is being splitted into two records and is being stored. Let us watch what are the anomalies that it causes. Like we had seen, three anomalies are there. One is insertion anomaly, update anomaly and the deletion anomaly. We can see here the insertion anomaly. Suppose if a new employee joins the company who is under training and currently not assigned to any department, then we would not be able to insert the data into the table if employee department field does not allow nulls. So let us take the case of this table wherein which a trainee joined and EMP ID has been generated, however the department is not been specified. So it is left blank. So this kind of anomaly, this is suffering with non-information in the field called as employee department against the trainee. So this kind of anomaly is called as the insertion anomaly. Then comes the update anomaly. In the table we have two rows for employee Rahul, as he belongs to two departments of the company. If we want to update the address of Rahul, then we have to update it twice. Why? Because two different records are being stored against two departments of the same person. So once we change the address in the first record, obviously it does not reflect in the second record. We have to manually change in the first as well as the second record. There is no relationship between the first record and the second record. So here exists the update anomaly. Likewise, you have the deletion anomaly also. Or else we continue, if someone, there are other things also which should be looked into. If someone, the correct address gets updated in one department but not in the other, as per the database, Rahul would be having two different addresses, which is incorrect and which may lead to the inconsistency of the data. And then there may be a kind of redundancy also. Storing the same information several times in the database can result in update anomalies, or else it is a kind of wastage of space. The same person record is being stored several times. Just for the variation of one field, it is being stored in the physically on the database several times. So that leads to wastage of space also. We can reduce redundancy by placing a relation schema with several smaller relational schema. So what we can do is we can split that particular relation, the table, into simpler relation schemas. That process is called as the decomposition. So how to do? Let us see in the Ju slides. Let us see the deletion anomaly. Suppose if at a point of time the company closes the department D801, then deleting that row obviously deletes the employee also. Suppose if we are identifying that particular row and then if you want to delete that particular row, employee department, then obviously the name called as Mohan stored against it will also be deleted. So this kind of anomaly is called as the deletion anomaly. So directly from the conversion of the relations by looking into the entity relationship diagram leads to certain kinds of anomalies. So directly we should not design the database and use it for application design. You have to do normalization process and then only you can use in order to avoid the redundancies, data inconsistencies and the anomalies that we had seen. So the process that we have to follow is the normalization process. In this process, it is nothing but it organizes the data in the database to avoid, one is the data redundancy and the anomalies, all the three anomalies that we had seen. So how to reduce or else how to reduce to various normal forms? Let us see. There are Several kinds of normal forms starts with first normal form 1NF, second normal form, third, Boy's code normal form, fourth normal form, fifth normal form, and you have one thing called as project join normal form PJNF, and then there is another thing called as domain key normal form. There are several normal forms. So we have to see all the redundancies be avoided, all the anomalies are being rectified. So these particular things we have to take care whenever we see the relations. If at all these things are being gone, then you can identify that as the final database and you can use. A normal form is a property of relation schema indicating the type of redundancy that the relation scheme exhibits. Suppose if it is in the second normal form, means it has been rectified with the first normal form. If the relation we are doing working for the second normal form, means directly we can't go to the second normal form, working of second normal form. We first of all we see that it is in the first normal form, then only we can work the like a functional thing of the second normal form. Likewise, if we are in the third normal form, means it should satisfy the condition, all the conditions till second normal form, then only we can work with the condition of the third normal form. Normalization for a given relation, what is the process that needs to be followed? First of all, specify the key of the relation, then specify the functional dependencies of the relation. See within the columns what are the functional dependencies, and then apply the definition of each normal form starting with first NF. That is what I am telling you. Directly you can't skip on 2 or 3 normal forms and jump on to the BCNF or so. Identify the key, then identify the functional dependencies and start working from right from the first NF. Whether it is satisfying one NF or not, then only you move to the second NF. Then if a relation fails to meet the definition of a normal form, change the relation until it meets the definition. So for each and every normal form there is a fixed definition, and you see, you verify after like splitting the relation, you verify whether it is satisfying or not. Then retest the modified new relations to ensure they met the definitions of each normal form. If at all everything is done, then you can call that particular relation as the final relation and you can take it as the final go. Otherwise, once again you have to follow the iterative way by skipping to the next step. So let us start the first normal form, which relations are called as 1NF satisfied for normal forms. As per first normal form, an attribute of a table cannot hold multiple values. It should hold only one atomic value. All values of a given attribute must be of the same type. So the data type here plays the prominent role. Whatever the column is meant for, only that data needs to be stored. Each attribute name must be unique. The order of attributes is insignificant. Where the ename is appearing, where the e number is appearing, where the address column is appearing, that is irrelevant and it is insignificant. And then no two tuples in a relation can be identical, as we had told earlier also. The order of the tuples also is insignificant. The order of rows is insignificant. The order of columns is also insignificant. The only thing we have to see is each and every column should contain atomic value, a single value of the same type. So let us see an example over here. Suppose a company wants to store the names and contact details of its employees. It creates a table that looks like the one we are seeing here: employee number, employee name, address and then phone number. Here for some of the records like Jairam, employee name with Jairam, he is storing 2, it is allowing to store 2 phone numbers under the same column, under the same record. So it does not happen. So by looking into this, you can identify that it is suffering with some sort of anomaly. So it is suffering with some sort of first normal form. So the first normal form says that the column, every column in the table should have one atomic value of the same type. However, it is storing 2 different values under the same record. So here you have to split out this and you have to work in the fashion that is shown in the next slide. So this table is not in 1NF, as the rule says each attribute of a table must have atomic value, and here the phone number column of Jairam and Lokesh violates the rule and it is storing 2 telephone numbers against the same column. So, here we had split it to employee number, and wherever it is storing 2 different values under the same column, we had split it to 2 records, one record with one number and the other record with the other number. So, here you can see with each and every record it is having an independent value of the same type stored against each and every column. So, now that particular first normal form is being satisfied. So, let us see the definition of the second normal form. A second normal form is nothing but a relation is to be in second normal form if it is in first normal form. So, this is must. Whatever the relation that we check for, we check from right from the start, that is right from the first normal form. So, whenever we are looking for the second normal form, first of all it should satisfy the first normal form norm, that is the atomic value normal form, and then only we can go ahead. And all of its non-key attributes are dependent on all of the key. So, that thing we have to see. Or else another way also is there to say the same action, that is a relation is in second normal form if it is free from partial key dependencies. So, this partial key is nothing but the key which does not have any prominence. These relations that have a single attribute for a key are automatically in 2NF. This is one reason why we often use artificial identifiers as keys. Let us see over here, one relation called as stocks is there. It is having the columns or attributes company, symbol, headquarters, date and then close price. This relation is not in 2NF. Why? We have to watch the functional dependencies. Let us see what functional dependencies are there. In order to start the normalization process, we have to functional dependencies in place. Here first functional dependency is saying that symbol and date functionally determines the company, headquarters and the close price. And then there is another functional dependency called as symbol. Symbol functionally determines the company and headquarters. Consider here that the symbol date functionally determining the close price. So, this close price is dependent on the symbol as well as combination of symbol and the date. So, we might use the symbol date as our key. However, we also see that symbol directly, symbol is functionally determining the headquarters also. You can see over here, symbol functionally determines the headquarters also, or else symbol and then the date are determining the value of that particular close price of the stock of that particular date, the company's value. So, here this violates the rule of the second normal form in that a part of our key, the key determines a non-key attribute. Another name for this is a partial key dependency. Symbol is not a part of the key and determining a non-key attribute. And also consider the insertion deletion anomalies also. So, this insertion anomaly is present over here as well as the deletion anomaly is also present over here. So, this particular relation is suffering with second normal form. Here each and every row is having a atomic value. So, there it is not suffering with the first normal form, it is in the first normal form and we are trying to do proper thing for the second normal form. So, the solution is that split this up into 2 different relations, one as the company and the second relation as the stock prices. So, the complete stocks relations we broke down that relation to 2 relations, one is company and other is the stock prices. So, here you can see the company relation consists of company, symbol and then headquarters, and stock prices relation consists of symbol, date and then the close price. At this point we have 2 new relations instead of one relation called as the stocks, and we started we decomposed the one relation to 2 relations. company and the stock prices. So, it appears similar to the one that I am showing over here. Here the company, symbol and headquarters are mentioned in one table, and then in the second table stock prices are mentioned. Here you can see the functional dependency 1, symbol determines, this symbol functionally determines the company and headquarters. Whenever I try to remove the symbol completely, the record can be removed, or else whenever I want to insert a new symbol for a company and headquarters, that also I can use. So, it is not suffering with the insertion anomaly and it is not suffering with the deletion anomaly also. So, let us talk about this particular relation. Here functional dependency like symbol comma date functionally determines the close price. So, for that particular date, the stock price can be, whatever the close price of the stock can be identified. So, this is functional dependency 2. As per the functional dependency 2, we had broke down the table to stock prices, and here you can see the columns called as symbol, date and then the close price. So, here also there is no insertion anomaly or else the deletion anomaly. So, now you can say with these particulars decomposition into the two tables, one is the company table and the other stock prices table. This relation stocks, earlier we were talking about stocks, the relation is now in 2NF after breaking down into two relations. In checking these new relations, we can confirm that they meet the definition of 1NF each one as well as 2NF. There is no partial key dependencies existing in the tables. So, before concluding the session, let us recap. In this particular session, we had seen that after designing the tables by looking into the entity relationship diagram, the tables that we get are the unnormalized tables. So, those unnormalized tables suffers with various anomalies like the insertion anomaly, the deletion anomaly and the update anomaly. We had seen with the help of an example how the insertion anomaly is present, the deletion and the update anomalies were present in the tables. So, after that we had seen the various kinds of normal forms. In order to perform the normalization procedure, we had seen various types of normal forms, wherein which there are several normal forms, and for each and every normal form associated with, there is a kind of fixed rules to be followed. So, in this discussion we had concentrated on the first normal form and the second normal form. First normal form says about that each and every column should have one value, that to atomic value with the same domain type, and in the 2NF we had seen that no partial key dependencies should exist. So, with this I hope you understood the normalization procedures for the first normal form and the second normal form, and in the next sessions the rest of the normal forms can be looked into. Thank you.